Now we're going to talk about the hardware features on our robot. The first major hardware feature is the scissor lift that we used. The scissor lift was a problem because at low angles, it was really hard for the motor to lift, and so we actually ended up using a slower speed at low angles and 2 springs in series on the shaft for the initial lift of the bucket. As the bucket got higher, the speed of the motor increased. On our robot, we also used 2 separate IR sensors in front and back so that we wouldn't have to waste time spinning around in the center to find the lit up corners. To trigger the ball dispenser, we used an LED instead of a moving servo because the LED was much more simple to set up and fired much quicker than a servo would have. Another notable hardware feature were the bumpers, the acrylic bumpers that we used. Our robot had huge friction when it reached to the corners of the arena, and using these bumpers helped it to slide quickly.
Regarding our important design decisions, our robot was heavily inspired by simplicity. We wanted a robot that was robust and that had as few features as possible that could go wrong. Because of this, we decided to go with the dumping strategy because we thought it was safer and more simplistic. Regarding our materials, we decided to use a clear acrylic base, a 1/4 inch so that it could support the weight of the batteries and the motors. We also went with a lightweight bucket made out of a foam board so that it would be less weight for the motor of the lift to support. We laser cut our scissor lift from acrylic with specific dimensions so that the bolts holding it together threaded directly onto the inner side of the scissor lift, allowing for less components and reducing lift friction. And we lastly soldered protoboards to make permanent circuits, which cleaned up our wiring and ensured the best electrical connections possible.
The goal of our code was to be as simple as possible. We didn't want to have any issues coming from the coding side of things, so we decided the easiest way to do this was to block code the navigation and direction. What this allowed us to do was to easily go back through the code and see what needed to be fixed after trying out the robot inside of the arena. In order to do block coding, we had to try a lot of different values and see what worked and what didn't, and we had to go back through the code, updating numbers and whatnot. And to make this more efficient, we decided to make a lot of global variables. So we had variables at the top with the values for things such as how many rotations we wanted the wheels to turn, the threshold voltage for the IR sensors, and things like that, such that after a trial run, we could easily go back to the code just right at the top there and update these values. This greatly simplified trying out different values because we could quickly go update the code, re-download it, try again. Our code also was very linear. It had a block for finding the IR sensor, going to the dispenser, dispensing the balls, and then it also used an if-else statement, and it had a variable that would track if the opposite corner was emitting infrared, then we would turn, and it would keep track of if we had turned previously or not. This allowed for greater simplicity in the code as we did not have to have a lot of values and sensors tracking what all the robot had done. We also selected pins on the pick that were close together such that we could use a simple ribbon cable from the motor or driver board to our pick. This greatly simplified the wiring.
So one of the cool things about our robot was the Adafruit soundboard that we implemented into the bot to play the Power Rangers theme song during the competition. The soundboard is actually controlled by a MOSFET, which makes the board play the audio file when the pick sends a high signal through a pin. Now, some of the lessons that we learned, to start off with, we were kind of frustrated that a lot of the parts that we had kept failing. I think next time we would definitely use higher quality parts. When going along with that, our wire management was very iffy, and we ran into some problems with some really poor wire connections, so we'd probably redo the whole wiring system. Also, possibly we could have tried a higher powered motor for driving the lift just so we didn't have to run into torque versus speed problems. Also, for more permanent solutions, when we ran into problems, we were just using tape, so we felt like something a little bit more permanent could be better. We feel like all of this could really be fixed by just making a really, really good plan at the beginning, and then carrying out that plan so that we don't have to make these really large modifications later on.